Right, good. Mr. Rops here. Today we're going to talk about linear combinations of Poisson and normal random variables. And so, take a moment, read this problem, and get a sense of what's going on. And once you've done that, you'll recognize that going into intersection A, we know it is a Poisson variable with a mean and variance of 9. And B is also a Poisson variable. The cars going in from B, and they're going in at 12 cars per minute. So A part says we want to find the probability that A is more than 10 cars, which means that it's going to be 1 minus the probability that A is less than or equal to 10 cars. Because it doesn't include 10, and Poisson distributions are discrete, so they're actual whole numbers, and the calculator only works from going from the 0 all the way up to the 10. So throwing this into my calculator, I go 1 minus, if I go variables, and I'm going to go, distributions. I'm going to go to Poisson CDF, number D here on my calculator. And I'm going to go from mean to 9, I'm going to go up to 9, and find that value, and I end up with 29.4%. This is equal to 0.294. So the probability there's more than 10 cars going in from the intersection A is 29%. B part now says, what's the probability that more than 10 cars are arriving from B? So now I go to the probability that B is bigger than 10. Well, similarly, I'm going to go 1 minus the probability that B is less than or equal to 10. If I throw this in my calculator as well, I can just go up here. I know that B, though, is 12. Insert the 2. And this is 65.3%. All right, so there's A and B. So now for C part, it says write down the mean and variance of the random variables of A and B. Well, if we remember, the expected value of A is 9. The variance, if it's a Poisson distribution of A, is also 9. Variance and the mean are equal for Poisson, and that's what part of a definition of Poisson. Similarly, when I look at the expected value for B, that's 12, and so therefore the variance of B is also 12. Okay, so D part now says, consider that C is determined by the cars entering from A and B. So here's C, A and B, they're coming in to my intersection, and so C is equal to A plus B. I want to determine the mean and variance of C. Well, we remember, so the expected value of C is going to be the same thing as the expected value of A plus B. So I get the expected value of A plus the expected value of B by our random variable algebra, and so it ends up being 9 plus 12, which I know is 21. Similarly, if I want to find the variance of V, well, the variance of C will be the variance of A plus B. When I add variances, or add random variables, I still add the variances. Remember, if I would have subtract the random variable, I still add variances. Always adding variances. Well, since these are 9 and 12 as well, my variance is also 21. And so what I can say, hence, what can I say about C? C now is a Poisson random variable because the variance and the expectation are both the same. So if I want to generalize this, if I say, like, let's say Z is equal to X plus Y, where X is some Poisson that has alpha as my mean, and Y is another Poisson variable that has, let's say, lambda as my mean, well, then Z is also going to be Poisson with a mean of alpha plus lambda. The variance will also be alpha plus lambda. And so the moral of the story is if you have two Poisson random variables and you combine them by addition, then you get a new Poisson random variable. Okay, so there's the generalization. It's a key result. Continuing on, E is what's the probability at any minute more than 20 cars join into street C? Well, now from here, if I consider C is Poisson with expected value of 21, I want the probability that C is more than 20 cars. From my problem here, it says more than 20 cars, so that's going to be 1 minus the probability of C less than or equal to 20, which using my calculator, I'm going to go 1 minus Poisson CDF. My mean is 21, and I'm going up to 20. And I can see that the probability is 0.529 of being 20 cars into the intersection. And then finally, the last part, F, says the capacity of street C, this street C, is a maximum of 30 cars per minute. If the limit is exceeded, then a traffic jam will develop. What's the probability that at any minute in the morning rush hour traffic, there'll be a traffic jam? Well, if it exceeds 30 cars per minute, so that means what's the probability that C is more than 30 cars? And so that again is going to be 1 minus the probability that C is less than or equal to 30. And if I do that in my calculator, which I've already done, I get 0.0242. Okay, so the big idea here is we're using Poisson to find probabilities, but we can combine Poisson random variables into new Poisson random variables if we are purely adding them together.